What if the ground beneath our feet is hiding more secrets than we realize? Beneath the seemingly simple movement of sand, rocks, or snow, unseen swirling currents may be quietly shaping powerful forces like avalanches and landslides. Most people see these shifting materials as straightforward. Everything tumbles downhill, right? But here's where it gets controversial. New research has revealed intricate, hidden flows working below the surface, challenging what we thought we knew about granular movement. When you watch grains spill during a landslide, nearly all follow the steepest downward path. This is known as the primary flow, with the particles moving together like a group following the crowd. But, and this is the part most people miss, some grains don't play along. They veer off, swirling sideways, tracing out complex secondary currents that scientists have long theorized about, but never directly witnessed. Why does this matter? Understanding what goes on beneath the surface can transform how we view the physics of granular materials. It could unlock answers about the forces driving avalanches and landslides, and even improve how industries move grains, from wheat in silos to powders in medicine. Here's the real breakthrough. Until recently, no one could actually see these hidden swirls in real-world conditions. Earlier studies relied heavily on computer simulations portraying grains in idealized scenarios, like rotating cylinders, or used mathematical models to predict these secondary flows. But translating theory into real-life observation was a massive challenge. To probe the inner workings of moving grains, scientists either had to freeze the action for traditional X-ray scans. Setting out to solve this puzzle, researchers designed a clever bulldozing test with glass beads, a near-perfect stand-in for sand, in which grains were pushed by a conveyor belt into a wall, building up a pile. In the laboratory, a brand new technique called X-ray rheography was developed, capable of capturing three-dimensional images of moving grains in real time. The system, known as Dynamics, provided an unprecedented peek under the surface without disturbing the flow. To everyone's surprise, the experiment revealed ripples forming on top, previously only explained by theory. These ripples lined up perfectly with predictions about the elusive secondary flows. For the first time, scientists could watch these movements unfold live, preserving the natural behavior of the beads. However, there's a twist. Due to the complex geometry involved, researchers could only fully measure the flow along the main conveyor belt direction, while the complete 3D picture remains partly obscured. Is this a limitation we should accept, or is there more yet to uncover? Determined to fill in the missing details, the team went further. They mapped the surface of the grain pile using refined X-ray imaging, connecting tiny ripples on the top to swirling patterns below. Measurements traced how grains move not only downward, but also sideways, providing the very first direct experimental evidence of secondary flows. Diving into these hidden swirls is rewriting our understanding of granular materials. Sometimes these materials act like solid objects, supporting heavy loads and forming stable piles. Other times, they mimic fluids, swirling and shifting unpredictably. It's this versatility and unpredictability that makes them so scientifically fascinating and so important in practical applications. And here's another bold statement. These swirling currents aren't limited to landslides. The experimental results show that whenever grains are pushed, from snow being plowed to grains moving in a farming context, secondary flows are almost always present. While the study didn't focus directly on landslides, it delivered new insights that could help explain how these disasters travel so far and so quickly, often outpacing current safety models. That's the controversial part. Most existing models ignore secondary flows entirely, leaving their predictions incomplete. This new research provides vital data for scientists to finally begin validating and refining these models. If engineers and planners can incorporate these invisible swirls, they might better forecast the reach and risk of landslides, improve safety protocols, and fine-tune how industries handle granular materials. The implications go even further. Powder handling in pharmaceutical manufacturing, efficient snow removal, grain transport in agriculture, and more could all benefit from a deeper understanding of secondary flows. So what does all of this mean for the future of science and safety? Whenever you see a pile of grains, be it sand, snow, or even industrial powders, remember, swirling currents might be shaping its motion more than meets the eye. Should we be rethinking our entire approach to modeling granular flows? Do you believe these hidden swirls should become a standard consideration in engineering and disaster planning? Or do you think secondary flows are too subtle to make a real difference? Let's get a heated discussion going in the comments. Your perspective matters.